So let's try another accelerated motion problem. This time I'm going to put a boat in water. So here's my little boat. Got the outboard going on there, kicking up a little bit of water. Let's say I start at 0 meters per second. And this time I know that at some later time, I'm going to have a final velocity of 4.12. So initial velocity is 0, final velocity is 4.12. Let's say that the acceleration is constant. And let's say that the time in this situation is 4.77 seconds. Okay, again, I want to know what the displacement is. So different from the last problem is that we don't have the acceleration, but we do know that it's constant. That's the key. If it's constant, then our equations of motion are valid. Once again, I think it's just a good idea. Get into the habit. Just rewrite them quick. It doesn't take that long. See, when you do them like this repetition, you don't need formula cards anymore, because you'll have memorized them through practice. Okay, knowns and unknowns. Do you know the acceleration? No. Will equation 1 work? In and of itself, no. Sure, we could solve for the acceleration and then put it back into another equation, but there's no real point in doing that. How about the fourth one? Would that allow us to do it? No, because we need to know the acceleration, so that's an unknown. Third one? No again, because we have an accelerated term there. So it's the second one again, right? So delta x being equal to 1/2 Vf plus Vi delta t, which is equal to 1/2 of 4.12 plus 0. That's the average. Average velocity, 4.77 seconds. .83 meters. So if we wanted to prove it, we could go back and look at this question again. Maybe we'd want to solve for time first. We could then substitute back into a different equation, perhaps the third one, and using the time. Well, I suppose, no, that would not work, would it? That's kind of silly. But initial and final velocity, knowing the time, we can find the acceleration once we have the acceleration. Then we could go back and use the third one. Or we could use the fourth one. But my thought is, why? If you have one equation that will solve that problem, it's elegant and it's simple. Go with that.